You ever pick something up, your phone, a new tool, anything, and just feel how perfect it is? It feels solid, everything lines up? Well, that feeling is no accident. There's this whole invisible world of quality control making that happen. Today, we're going to pull back the curtain and take a look inside. So let's start with that question. What does perfect even mean when we're talking about a product? Is it that it looks flawless, that all the parts fit together with, zero gaps? Or is it just that it works the way it's supposed to every single time? That sense of quality, that's what we're talking about. Because in reality, getting to that point is a constant fight. Seriously. Behind the scenes in every factory, there's basically a war being waged on imperfection. A battle against thousands of tiny potential flaws that, if they do their job right, you'll never even know were a possibility.
All right, so to win any war, you've got to know your enemy, right? So let's dive in and look at the anatomy of a defect. We need to understand exactly what these manufacturers are up against.
It's pretty wild how something this tiny can be such a huge deal. So, meet the burr. It's just a little, sharp, raised edge of leftover material. Seems like no biggie, right? Wrong. If you don't get rid of it, parts won't fit together, things will wear out way too fast. It can even be a safety hazard. Now let's zoom in, way in, like microscopic level. We're talking about surface roughness. Even if a part looks totally smooth, its microscopic texture can change everything. How it deals with friction, how long it lasts, how well it seals, or even just, how good it looks.
And then you've got the enemies you can't even see. Porosity. It's basically tiny little holes or voids trapped inside the material itself. Think of it like little air bubbles in a metal sponge. From the outside, it looks fine, but on the inside, those bubbles are weakening the whole structure, just waiting to cause a failure.
And this is just scratching the surface. The list of things that can go wrong is huge. A part could be just slightly the wrong shape because the temperature in the factory changed. The tools making the part could be wearing out. You could have tiny misplaced balls of solder on a circuit board. I mean, the variety is just mind-boggling. So, with all these potential gremlins in the system, how in the world do you find them? Well, let's look at how the watchful eye guarding the assembly line has evolved over the years. For the longest time, quality control was just people. Literally people staring at parts, looking for problems. And humans are pretty good. But we get tired, our eyes play tricks on us. So the game really changed with the shift to automated monitoring. Using tech gives you a system that's incredibly fast, super precise, and it can work 24/7 without ever getting bored. And today, that automation is getting a serious brain upgrade with AI. Think of it like a security camera with a PhD. You show the AI thousands of pictures of perfect parts and thousands of pictures of parts with every defect imaginable. It learns. And once it's trained, it can spot a flaw on a moving assembly line in a blink of an eye. It's incredible. But, okay, what about those hidden flaws? The ones like porosity that are hiding under the surface. For that, you need a kind of industrial superpower. You need X-ray vision. It's called non-destructive testing, or NDT, and it's a whole family of amazing techniques that let inspectors see the inside of a part without, destroying it. This is absolutely critical for things like airplane parts or car components. You have to know what's going on inside because failure there is just not an option. Finding flaws after they've happened is good. It's important. But what if you could stop them from happening in the first place? This is where we go to the next level. From finding flaws to literally seeing the future. And the secret really boils down to this one simple idea. Good quality comes from healthy machines. A machine that's running perfectly makes perfect parts. A machine that's starting to wear out, it starts making flawed parts. It's a direct relationship. You can see that cause and effect so clearly here. As a cutting tool gets worn down, the product's surface finish gets worse. Simple as that. If a machine starts to vibrate just a tiny bit more than it should, the parts it makes start to lose their perfect shape. So by watching the machine, you're actually watching the quality of the product being made in real time. This is the whole idea behind predictive health management. Instead of waiting for a machine to break down and ruin a whole batch of products, you have sensors watching it constantly. It's like having a check engine light for your factory that warns you about a problem way before it becomes a disaster. So we've gone from finding flaws to predicting them. What's the final frontier? It's taking full command of the entire process and actively stopping defects from ever even forming. A modern factory has this whole dashboard of controls, all these levers it can pull. Using real-time data, automated systems can tweak things on the fly, the speed, the temperature, the flow of materials, constantly making tiny adjustments to keep production in that perfect sweet spot for quality. And these aren't just random tweaks. They're all guided by a larger strategic rulebook. You've got these big picture philosophies, like lean manufacturing, which is all about cutting out waste. And then you have incredibly detailed methods like fault tree analysis that let engineers trace a tiny problem all the way back to its root cause so they can eliminate it for good.
So, when you put it all together, this journey from just catching mistakes to predicting and preventing them, what does that really tell us about the future of how we make things?
Here's the big takeaway. The goal isn't just about having a really good inspector at the end of the line anymore. The real cutting edge is to design a process that's so smart, so robust, and so good at correcting itself that making a mistake becomes almost impossible in the first place.
And that leaves us with a really fascinating thought to chew on. As we get better and better at designing failure completely out of the system, what does that unlock? What kinds of things can we create when perfection isn't some aspirational goal, but just the starting point?